Show by calculation that the equation cos x minus 2x is equal to 0 has a root between x is equal to 0 and x is equal to pi by 4. Use the iterative formula x to the n plus 1 is equal to half cos x, starting with x1 equal to 0.5. Find this root correct to 2 decimal places. Right, notice that x is in radians, so on your calculator you must make sure you're in radian mode. So when x is equal to 0, cos of 0 minus 2 times 0 is going to be equal to 1. So we put in the first value here, and when x is equal to pi by 4, cos of pi by 4 minus 2 times pi by 4 is 0.864. As we've gone from being positive to negative again, there must be a root between those two values. As the sign changes between x is equal to 0 and x is equal to pi by 4, there must be a root in the interval. Right, so there's the actual cos x minus 2x as it's drawn, and there in fact we can see what the root should actually be. Okay, to solve cos x minus 2x is equal to 0, then we will rearrange this to make x a subject. So we've got cos x is equal to 2x, so x will be equal to a half cos x, and so we'll use the iteration formula, x to the n plus 1 is equal to a half cos x to the n, with x being measured in radians, starting with the starting value of 0.5. So x1 will be equal to 0.5, x2 will be a half cos of 0.5, again it's an easy way of doing this on the calculator which gives that value. x3 will be equal to a half cos 0.4387, which is 0.4526. x4 will be equal to a half cos of 4526. What you do is, remember, you put the previous value in, you get 0.4496. x5 is equal to a half cos 0.4496, which is 0.4502. x6 is equal to a half cos 0.4502, which is equal to 0.4501. Therefore, the root is going to be, because we've now got agreement here to 2 decimal places, before that we didn't, therefore the root will be 0.45 to 2 decimal places. Okay, so here's a picture of the iteration formula. However, if we go to the actual live applet, okay, here I actually have a starting value of 0.75. okay, instead of it goes up, okay, and this time it goes to y is equal to x, but actually this time instead of going round it actually spirals round, okay, which you're spiraling round onto the root. So if I enlarge this a little bit at the top here, you can see that a little bit better. So move that down and then I'll keep enlarging it. I have to center it. Okay, I'm just going to keep centering it and you'll see what I mean by spiraling around. So to center this bit now. Okay, hopefully there you can see it's actually spiraling around onto the root as opposed to going down on sort of a ladder for the format. So we'll just go back to like where we were to begin with if possible. We might have to move the, so get the axis to reappear. Okay, and therefore if I now move this, if I now move this to 0.5, this is what actually happened in our case, and therefore we can see it converging onto 0.45. It actually would stop here where we stopped. Okay, so that's a brief introduction to iteration again.